Here is the first problem. The Venn diagram shows the events A, B, and C, and their associated probabilities. Problem A. Find the probability of the B complement. So we have to shade the area of B complement. We shade the area that is not B, which is this one. And you can see that the probability in the blue areas are the probabilities for the B complement. We can add all of them together. 0.15 plus 0.13 plus 0.12. And the answer is 0.4. That's the answer for the first one. Let's move on to the next one. Find the probability of A union C. So we erase the previous one first. And now we shade A union C. A union C means A or C. So this is A or C. 0.15 plus 0.2 plus 0.23 plus 0.12, which is 0.7. And then problem C. This one is a conditional probability. We need to find the probability of A given B complement. That means we have to find the area of A in the area of B complement. First of all, we should write down the equation first. So P A given B complement is P of A intersect B complement divided by P B complement. Okay, now let's find A intersect B complement. According to this one, B complement is here. This is B complement. Again, we've got all of the B complement in the blue areas. And then intersect A. So the overlap part of the blue area with the A is this one. Just only this part. So that means probability of A intersect B complement is 0.15. Just the overlap part between B complement and A. 0.15 divided by the probability of B complement, which is the first one, the one that we've got in problem A. So we put it down here, and the answer is 3/8. For problem 2, we've got the stem and leaf diagram. It shows the ages and years of the residents in a care home. The key for 3 means the age of 43 years old. For the first problem, we have to find the median age of the residents. To find the median, we have to find the position of Q2. So the position of Q2 is 1/2 times N, which is the total data, plus 1. 1/2. We can find N by adding all these terms together, which is 31. Here is 31 plus 1, which is 16. That means the position of Q2 is going to be in the 15th position. So you keep counting all these numbers, and the 16th is going to be at 74. So Q2, or the median, is 74. Next, find the interquartile range of the ages of the residents. In the interquartile range, we need to find Q3 and Q1. So Q1 is a quarter of N plus 1, which is a quarter of 31, which is a total data, plus 1. So we've got 1/4 times 32, and then it will be the 8th position. This is the position of Q1. And we keep counting. 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th position, so Q1 or the lower quartile is 68. The lower quartile is 68. Now we can find Q3, which is 3/4 of n plus 1, which is 3/4 of 32. And the answer is 24. So the position of Q3 is the 24th position. So if I Q3 in the 24th position, it's going to be 80. Q3, hence Q3 is 80. Now we've got Q3 and Q1, so then we can find the interquartile range. The interquartile range is Q3 minus Q1, which is 80 minus 68, which is 12. And that's the answer. Let's move on to problem C. An outlier is defined as a value that is either more than 1.5 times the interquartile range below the lower quartile, which is Q1. This one is Q1. Or more than 1.5 times the interquartile range above the upper quartile, which is Q3. So we have to find all these quantities, so then we can identify the outliers. Here's problem C. 1.5 times interquartile range is 1.5 times 12 from the previous problem, which is 18. So the outlier has to be more than 1.5 times interquartile range below the lower quartile. So 1.5 times interquartile range below Q1. That means we have to use Q1 subtract this whole thing. It has to be less than this one. So Q1 is 68 minus this term, which is 18. So we put 18 in here, and the outlier has to be less than 50. On the other hand, it has to be greater than Q3 plus 1.5 times the interquartile range, which is 80 plus 18. So the outliers have to be above 98. For overall, the outliers have to be located anywhere below 50 or greater than 98. You can try to locate this one from your data. You see that 97 is still less than 98. So this one is not the outlier. It has to be below 50. So this term is below 50, 43. So that's why 43 is the outlier. For problem D, we have to draw a box plot to summarize this data. In a box plot, we need all of this data. And from the previous problem, we've got the outlier, which is 43. 43 is the minimum data, but right now it's an outlier. So the new minimum data is the next number, which is 54. And since we don't have any outlier, so then 97 is to be the maximum number. And now we can plot all of this data into the scale. When 43 is the outlier, right here. And the minimum is 54. which is this one. And then Q1 is 68, is right here. And Q2 is 74, which is this one. Q3 is 80. Put it right here. And then the maximum is 97. 97 is right here. Now you can draw a box and whiskers. That's it. Here is problem 3. The weights of packages that arrive at a factory are normally distributed with a mean of 18 kilograms and a standard deviation of 5.4 kilograms. The first one, find the probability that a randomly selected package weighs less than 10 kilograms. First of all, we define a random variable by letting W to be weights of packages delivered to the factory. Then we divide the distribution of W, which is the normal distribution of the mean of 18, and the standard deviation of 5.4 means the variance is 5.4 squared. Then we find the probability that the weight is less than 10 kilograms. So to find this one, we start with this term, PW less than 10. And we are going to change this one, the random variable W, to a standard normal distribution, which is represented by the probability of Z less than 10 minus mean, which is 18, divided by 5.4. And this one would be the probability of Z less than negative 1.481. If we draw this area, we have Z equals to minus 1.481, which is this area. But we can find this area in a Z table. So we can see that this area is equivalent to this area when Z is a positive 1.481. And we can find this area from table. So that means the red area, this area, can be found by subtract this pink area from 1. So the pink area is represented by probability of Z less than 1.481. And we can use a Z table to find it. You can see that 1.481 is around here, so the probability is 0.9306. 0.9306. We calculate this term. The answer is 0.0694. And that's the probability when the weight is less than 10 kilograms. Let's move on to the next one. For problem B, the heaviest 15% of packages are moved around the factory by Gemina using a forklift truck. Find the weight in kilograms of the lightest of these packages that Gemina will move. According to this information, we can draw a diagram first. The heaviest 15% of packages have to be here, when W equals to something, which we have to find. This one will be 0.15. That means the area on the left is 0.85. Now we know that the probability of W less than this W will be the probability of Z less than W minus the mean, which is 18, divided by 4.5. And this one will equals to 0.85. In a Z table, we have to find the probability of Z less than something, that is equals to 0.85. According to the table, 0.85 is around here. That means Z is 1.04. So we put it back here, 1.04. Now we can see that this one equals to this one. W minus 18 over 4.5 equals 1.04. And we are going to solve for W. So W minus 18 is 1.04 times 4.5, which is 5.616. So W is 5.616 plus 18, which is 23.616. So that means W is 23.6 kilograms. For three significant figures. For problem C, one of the packages not moved by Gemini is selected at random. Find the probability that it weighs more than 18 kilograms. From the previous problem, we know that the heaviest 15% of the packages were moved by Gemini. So that means all the packages that are less than 23.6 kilograms will not be moved by her. So we're going to make it to be J complement. And then we have to find the probability that the weight is more than 18 kilograms. And according to this information, we know that W has the distribution of normal distribution with the mean of 18 and 4.5 squared. So 18 is the mean. That means W equals to 18 has to be here. To find the probability that it weighs more than 18 kilograms, we have to find it from the area that is less than 23.6. So in this problem, it's a conditional probability. We have to find the probability of W that is more than 18 kilograms from W less than 23.6 kilograms. We can write down the formula first. It will be probability of W greater than 18 intersects W less than 23.6 divided by probability of W less than 23.6. So for the top part, W has to be greater than 18 and also less than 23.6. So we can rewrite the top part to be this term. 18 less than W less than 23.6 divided by W less than 23.6. So to find this area, it has to be the area of W less than 23.6 subtract this area, the area of W less than 18. So we can rewrite the top part again by using probability of W less than 23.6 minus probability of W less than 18 divided by 23.6. From the previous problem, we know that the probability of W less than 23.6 is 0.85. And since W equals 18 is the mean, the area on the left-hand side is 0.5. So we're going to subtract them. Here, 85 minus 0.5 and divide by 0.85. It will be 0.35 divided by 0.85, which is 7 over 17, and can be routed by 0.412 for three significant figures. Now let's move to the last part of this problem. Problem D. A delivery of 4 packages is made to the factory. The weights of the packages are independent. Find the probability that exactly 2 of them will be moved by Gemini. In this case, we have 4 different packages. Suppose we have A, B, C, and D. All packages are different, so that means any of them will be moved by her. So we have 4 choose 2 ways to rearrange all of these packages. And 4 choose 2 is 6, so we have 6 ways to rearrange them. And according to the problem, we know that the heaviest 15% of the data were moved by Gemini. That means the probability of moving by Gemini is 0.15. It means that the probability of not being moved by Gemini is 0.85. So the probability that exactly 2 of them will be moved by Gemini is 0.15 squared. That means 2 of them will be moved by Gemini, and the other 2 of them won't be moved by her. 0.85 squared. And we have 6 ways to rearrange all of these 4 packages, so we have to multiply 6 here. And the answer will be 0.097535, which can be routed to 0.0975 for 3 significant figures. That's the end of problem 3.